right? And that is 5.88 times 10 to the negative fifth. So Q squared equals 5.88 times 10 to the negative fifth. All right? Or 0.0000588. Okay? So that's Q squared. So Q squared equals 0.0000588. Okay? So let's solve for Q. Q is going to equal Q is going to equal the square root of that. So 0.0000588. Okay, and my answer is going to be 0.0077. So I'm just going to round that. So Q is 0.0077. Okay. So P is going to equal 1 minus 0.0077. All right. And that is 0.009, so sorry, 0.9923. All right, and now solve for 2pq. All right, so we're going to solve for 2pq. So that's 2 times 5.88 times 10 to the negative fifth times 0.9923. Okay, so my answer right, 2 times is 1.1 times 10 to the negative 4. So that is the amount of individuals that will be carriers. And that equals big A, little a. Okay. All right. Oh, my apologies. I know I made a mistake here. This is tough to do when I'm not actually in class. Right, so that 5.88 5.88, right? We have to square root the 5.88. So that ends up being, my Q value is 0.0077. So, crap. Right, so 0.0077. Okay. So 2 times 0.0077 multiplied by 0.9923. Yeah, 0.02 is my answer there. Not 1.17 times 10 to the negative 4. 0.02 is my answer to that question. And that's because the Q squared is 5.88 times 10 to the negative 5. When I square root it, I get 0.0077. So my P is 0.9923. Okay, so go over that in your textbook, in your key as well. Okay, again, another good Hardy-Weinberg question. Sickle cell anemia is caused by the sickle trait HBS on a gene that contributes to hemoglobin production. The abnormal hemoglobin produced causes red blood cells to become deformed and block capillaries. Tissue damage results. Affected individuals homozygous for the sickle cell gene rarely survive to reproductive age. Heterozygous individuals produce both normal hemoglobin and a small percentage of hemoglobin sickled cells. These individuals are more resistant to malaria than individuals who are homozygous for the allele for normal hemoglobin. So this is page 137, by the way, question number 1. Okay. The red blood cells are prone to sickling when there is a deficiency of oxygen. The malaria-causing microorganism Plasmodium falciparum is injected by mosquitoes into the bloodstream of humans. Historically, the frequency of the HBS allele in Africa relates directly to the presence of malaria-causing organisms. So we talked about heterozygote advantage yesterday, right? The malaria infects the sickled cells, and the immune system wipes it out in areas that are malaria-stricken, right? So that's a natural selection piece. In Western Africa, the frequency of the HBS allele in the gene pool is 0.15. In Central Africa, the frequency is 0.10. And in Southern Africa, the frequency is 0.05. What is the frequency of the HBA allele in the human gene population? Okay, so these individuals are more resistant to malaria than those. Yeah, so HBA. So these individuals are more resistant to malaria than individuals who are homozygous for the allele for normal hemoglobin. So HBA is the normal allele. So what is the frequency of the HBA allele in the human gene pool in Western Africa? So when I look at these traits, right, we're looking at Western Africa, and that's 0.015. So it's telling us what the HBS allele is. So the HBS allele is 0.15, and it wants the HBA allele. So this one is actually a very simple question. It does not talk about genotypes. All it talks about is alleles. So all of that large explanation for a very simple question. Okay, so let's get rid of all this. Okay, so again, right? This would be normal. So actually, this guy would be P squared is HBA in this case. 2PQ is HBS. And the recessive condition is HBS. So P is HBA, okay, and Q is HBS. And what it gave me was the allele frequency of the sickled cells in Western Africa, right? So in Western Africa, the frequency of the HBS allele. So it didn't give me a genotype, it gave me allele frequency. So it gave me Q, and it's asking for what's the frequency of the normal allele. It's asking for this, so I go from here to that. All right, so all it is 1 minus Q equals P. So 1 minus 0.15 equals P, so 0.85 equals P. And that is it. Okay? So a fairly simple question, so B is my answer. All right, so so I'm going to leave numerical response number 1 on page 138 is another Hardy-Weinberg question, so work through that one. And page 139, I'm actually going to do this one, numerical response 2. So this says the gene for retinal disease, which causes blindness, is known to be a recessive allele. Okay, so let's use B here. Little b, little b. You have to be homozygous recessive in order to be blind in this case. In Michigan, 9 people in a sample of 10,000 were found to have retinal disease. In Wisconsin, 2,500 people were surveyed. If allele frequencies are the same in Wisconsin as they are in Michigan, how many people would be expected to have retinal disease in Wisconsin? So here's the deal with this. You don't actually need to do Hardy-Weinberg. This is just straight probability. So this is something that you'll see as well. So this is deliberately there to try and trick you a little bit, throw you off. This is a lot simpler question than you think it is. So if I look at Michigan, 9 out of 10,000, right? So 0.0004. Sorry, 0.0009. Okay, have retinal disease. And there are 2,500 people surveyed here. So 2,500 times 0.0009 would give you your answer. So about 2. So approximately 2. Right, that's about 2.25. Okay. And that's it for your key. I'm going to go back. So the Hardy-Weinberg assignment, you guys can do, I'm going to leave that up to you to do. You don't need to submit it or anything like that. You can use it as practice for the ecology unit test. I'm going to give you another assignment to do for ecology based on poaching. We do these for practice because there will be quite a few on your ecology unit test. But this is a really good question. Problem number 7 in your Hardy-Weinberg problems that I've given you. So this says, after graduation, you and 19 of your closest friends. So let's just write some stats down. So there's 20 people. Okay. What you do is you charter a plane to go on a round the world tour. Unfortunately, you all crash land on a deserted island. No one finds you, and you start a new population. Totally isolated from the rest of the world. That might be great for some of us St. Tim's grads. That might be horrible for others. 2 of your friends carry the recessive cystic fibrosis allele. So 2 of your friends are this. Big C, little c. Okay. So assuming that the frequency of this allele does not change as the population grows, what will be the incidence of cystic fibrosis on your island? So everyone else is healthy, so here's the deal, right? There is no CF. 2 are this. So 2 people are this, and there's no CF. Right? So no one is little c, so that means the rest are big C, so that's 18 people. Okay, so there's 20 total people, and remember that there's 2 alleles. There's 2 alleles for each person, right? So 20 times 2 equals 40 total alleles. Right? Okay, so I can find the frequency of Q, right? So 2 out of 40 is actually going to equal Q. Because 2 out of 40 are going to be little c. Right? So 2 out of 40. So this is a little bit of inductive reasoning. All right, so 2 out of 40 is 0.05. And from that, I can find P, right? So P equals 1 minus Q. And that is 1 minus 0.05. So P equals 0.95. Okay, so the question actually asks, what is the frequency of CF? So what is the frequency of little c is what the question is asking for. So if I go back to my equation, okay, if I go back to my equation here, there's only one genotype that's going to give me that, so little c. Right, so Q squared. So I know that 2 out of 40 alleles, because each has 2, is 0.5, right, and P is 0.95. Okay, when we do 1 minus P. So I can solve for Q squared. Okay, so Q squared will give me, right, so little c equals Q squared. So that's going to equal so Q is 0.05, so 0.05 squared equals little c. And that'll be the prevalence of cystic fibrosis on the island. So that's going to be relatively low, right? So 0.05 squared is 0.0025. Right, so 0.0025, or as a percentage, right, multiplied by 100, right, the frequency would be 0.25%. Okay, and that is how you do Hardy-Weinberg, okay? So again, the biggest thing to know is what you're being asked. What you're being asked to solve for and what you're being given. So it's a bit of reading comp. Excuse me. So if you know what you're being given and you know what you're being asked to find, Hardy-Weinberg is pretty straightforward. Okay. Do those practice questions from the Kansas State assignment that I gave you. There's explanation in the answers. You can work on them together. Okay, and then there'll be multiple Hardy-Weinberg questions on your unit test. So that is it for Hardy-Weinberg today. And I hope everyone's mental health is doing okay. As you can see, it's a bit of a struggle for me to do lectures like this, but we're managing. And we'll chat soon. Bye now.